Hi guys, today we are going to continue talking about conic sections. To be more specific, we are going to be talking about ellipse. So as previously mentioned, we are going to spread this section about 4 topics, okay? About 4 videos, my mistake. So in an earlier video, we talked about circles. We also talked about parabolas. And as you can see right now, we're going to talk about ellipse. For our 4th and final video in this series, we will table hyperbola. So ellipse, what is that? So pretty much unlike parabolas, an ellipse has more than one focus or foci or foci. I call it foci. I don't know how you call it, okay? Um, so pretty much the ellipse, we're going to take these 2 fixed points, and then we're going to take the sum of these distances, and that sum will always be fixed, okay? So we're going to take this point, circle it all around, and yeah, and all that good stuff. So maybe I should have just focused this video on how to graph. Okay, this is the first time that I'm playing with what is this, OneNote. So we're gonna see how this goes. Now like parabolas, we have for parabolas, we have sideways parabolas and then vertical parabolas. For ellipses, we also have a sideways ellipse or horizontal ellipse, and we also have vertical ellipse. Now, how can we tell if we're going to have a vertical or horizontal ellipse? Well, we're going to look at the major axes. So ellipses has more than one axis of symmetry to. So in this case, we have the longer axis or the major axis, and then the minor axis, which you guess it is the shorter one. The question is, when we look at the equation of an ellipse, how can we tell if we're going to have a vertical or horizontal ellipse? Well, let's go ahead and look at the standard equation of an ellipse. So we have square of x minus h over a squared plus square of y minus k over b squared equals 1, and then you can read the other one. As you can see, the equations look very similar, okay? We're squaring the x minus h on both. We're squaring the y minus k on both. We are adding, it's set equal to 1. We have a squared and we have a b squared. The difference is the location, okay? Now, what is so special about a? Okay, a represents the distance from the center to the vertex. Okay, so because for ellipses a is greater than b, then whatever variable is associated with a, that will dictate if we're going to have a vertical or horizontal ellipse. So bear with me. So in this case, for the equation on the left, that a is associated with the x kind of reminds me of the x kind of reminds me of the x-axis. So because the larger number, because remember a is bigger than b, because the larger number is associated with x, that means that we're gonna have a horizontal ellipse. So let me go ahead and see if I can zoom this in, because I told you this is my first time playing with this OneNote. Okay, so let's go ahead and identify the center. So first of all, which one is the major axis? So in this case, we had said that because a or the larger number is associated with x, then we're going to have a horizontal ellipse. So the major axis is right here. There is no need for me to trace it. It's already right there. Now, where are the vertices? The vertices are the endpoints of the major axis. So let me go ahead and highlight those for you. We're just going to abbreviate with uppercase V. Where are the foci? I YouTubed it, so that's why I say it like that, but I always say foci incorrectly. So the foci, plural form of focus, they are along the major axis. So they're not labeled in the picture that I found, so I'll just put them right here. Cool. So now, what about the value of A, B, and then C? Okay, so let's do this. C, what does that represent? C represents the distance from the center to one of the focus. So in this case, it's right here, or I can do it right here. Now, what about A? So A represents the distance from, where am I? Okay, A represents the distance from the center to the vertex. So let's go ahead, tag that up. Okay, so here's the center. We have the vertices right here, and that distance is given by A. Okay, maybe I shouldn't have written it right here. This looks ugly. Let me see if I can undo this. I promise I will be better in the next video. I lie. I'll try my best. Okay. So A represents distance from the center to the vertex. So right here. Now, what about B? Okay. So B, what's so special about that? New to your life? B represents the distance from the center to one of the endpoints on the minor axis. So let's go ahead, play with that. Okay, so the minor axis is the shorter axis. Where am I? Right here. The endpoints, let me go ahead, highlight them. What is B? B represents the distance from the center to the endpoints, or one of the endpoints. So this is B. Yeah, they didn't look so well because me tagging it up, but I'm hoping that I can better convey what I'm trying to say with an actual example. Now I could recycle the same speech identifying A and B. Well, yeah, why not? Okay, so A, first of all, let's go ahead and identify the center. Cool. All right, the major axis is the longer one. It's already traced right there. The vertices are the endpoints of the major axis. Let's go ahead, switch it up. Now, what is A? A represents the distance from the center to the vertex. So this will be our A. What is B? B represents the distance from the center to one of the endpoints. Let me do another color. B represents the distance from the center to one of the endpoints on the minor axis, or the shorter one. So this will be B. This will be B. Fantastic. Now, what about the focus, or C? Well, first of all, the focus is along the major axis. Let me go ahead and put F. Now, what does C represent? C represents the distance from the center to the focus. So if this is, the center is right here and the focus is over here, then this distance is given by C. Yeah, this looks like a crazy pizza. Sorry about that, but I'm trying to do what I can. Okay, what else do I want to say? The question is, do we have to memorize all these things right here? You know, formulas for the center, formulas for the vertices, formulas for the endpoints of the minor axis, formulas for the foci, length of major and minor axis. You know what? That's really a personal choice. Okay, what I recommend is this. So I said it before, since day one. Memorize what you have to, understand as much as you can. What is the structure for an ellipse, or the equation? Okay, so we have squares on both the x and y axis. Okay, we have a sum of squares. Okay, it's said equal to 1. Okay, now how can I tell if we're gonna have a vertical or horizontal ellipse? Well, that just depends who has the larger number. If the larger number is associated with x, if the larger numbers, so remember, A is bigger than B. If the larger numbers associated with x, think about the x-axis, so we have a horizontal ellipse. If the larger number is associated with y, so again, A has to be bigger than B. If the larger number is associated with y, think about the y-axis. So we'll have a vertical ellipse. What else do we need to have in the back of our mind? We have to have in the back of our mind what A, B, and C represent. Okay, so A represents distance from the center to the vertex. Okay, B represents what is that? Distance from the center to the endpoint of the minor axis. And C represents distance from the center to the foci. Okay, to the focus. Yeah, I'm trying to highlight something cool. Now the question is, how do we calculate C? This is something that I will need to have in the back of my mind. So we have C squared equals A squared minus B squared. Cool. Now if your teacher is nice, more than likely you will have probably maybe one cheat sheet on this. Cool. What else am I trying to stress? Okay, cool. So now our book focuses on ellipses that are centered on the origin. So let me go ahead, zoom this in. So the standard form of an ellipse, let me go ahead, write it like this. Square of x minus h over a squared plus square of y minus k over b squared. Yeah, my writing is terrible. Remind me to get a nice stylus. Okay. Now, if the a is associated with the x, then we're going to have a horizontal ellipse. Now in this case, we have standard equations that are centered at the origin, 0, 0. So in this case, h is 0 and k is 0. So this is why we have x minus h, or x minus 0, which will give us x squared, y minus k, or y minus 0, which will give us y squared. So we have standard equation of ellipse centered at the origin. Now, fantastic. So the question is, how can I tell if we're gonna have a vertical horizontal ellipse? It's the middle of the night, so I'm not quite sure if I said it before. So again, centered at the origin or not, for ellipse, one of the things that needs to have been met is that A is bigger than B. So again, am I gonna have a vertical or horizontal ellipse? Then just ask yourself, who's associated with A, or the bigger number? Equation on the left, A or the bigger number is associated with the x-axis, horizontal ellipse. Equation on the right, A or the larger number is associated with y or y-axis. And again, same speech. Do we have to memorize these things? I could tell you yes, but remember, memorize what you have to, digest what you can. When it comes to ellipses, I kid you not, if you just remember what A, B, C represent, the rest is history. What I will need to have in the back of my mind is that c squared equals a squared minus b squared. How do I remember that? I know it's a squared and something b squared. And the question is, should it be a plus or minus? I just ask myself, it's the operation of the ellipse. If ellipse needs to have a plus, well, guess what? The c squared needs to have a minus. Cool. So let's go ahead, look at fun problem number 1. So it says, graph the ellipse. Please locate at least 4 points on the graph. Include the graphs of the foci. Give the coordinates of the center, vertices, and foci. Give the length of the major and minor axes. So I would love to continue with this digital thing. I think it's pretty neat. I feel like a kid with a lollipop, but I am a little old school and my penmanship is not the best on here. So I'm going to take a quick pause and then I'm going to hook it up to my dinosaur, my document camera. I'll be right back. Alright guys, document camera has been located, so let's do this. So from the top, so we are asked to graph the ellipse. That is very nice that we're told what kind of a graph we're going to have. We are asked to locate at least 4 points on the graph, and we need to include the graphs of the foci. We are asked to give the coordinates of the center, vertices, and foci, and then give the length of the major and minor axes. Again, it's a lot of information. No, I'm not gonna downplay it. It is a lot, but if you keep your cool, you got this. Okay, so you can remember formulas or just remember what I said. If you're cool and remembering what the value of A, B, C is, whether the ellipse is centered at the origin or not, you're pretty much gonna be good. Okay, so first of all, this doesn't look like the standard equation of an ellipse, whether it's centered at the origin or not. Why not? The reason being is because the equation needs to be set equal to 1. Okay, so in order for the 36 to look like a 1, we're gonna go ahead, have to divide both sides by whatever that number is. In this case, it's 36. Okay, why? Because it needs to set equal to 1. So for an ellipse, the equation needs to be set equal to 1, else we don't have the standard equation of an ellipse. Okay, so when we keep our cool, 4x squared over 36, that will simplify. Let me go ahead, zoom in. Okay, so when we keep our cool, that will give us x squared over 9. You can go ahead, use your cross canceling notation, and then the second item, when we reduce it, 9 and 36 have a common factor of 9. That will leave us with y squared over 4 equals 1. Fantastic. We have something squared plus something squared equals 1. Now we are good to go. Now our book only focuses on ellipses centered at the origin. So it's up to you if you just want to focus on this or just the standard equation of an ellipse centered at HK. The choice is up to you. Again, for me, I like to memorize what I have to and then understand as much as I can. So I'm going to remember the equations for an ellipse centered not at the origin but with center HK. Okay, so general form, it should be something squared plus something squared equals 1, and then we'll talk about the a's, b's, c's in a bit. Okay, so we should have square of x minus h plus square of y minus k over something each, and that sum should equal 1. Okay, so we should have an a squared and a b squared, but the question is which one should be a squared, which of these two numbers should be a squared, and the other one, which one should be b. Bear in mind that when it comes to ellipse, the value of a always has to be greater than b. So whichever of these two numbers is bigger, that's going to be associated with a. Last time I checked, 9 is bigger than 4, so this is going to be associated with a. Okay, so in this case, we have a squared equals 9 and b squared equals 4. Why do we say a squared versus just a? Well, that's because that's the standard equation of an ellipse. Okay, so we have square of x minus h over a squared plus square of y minus k over b squared. Okay, if the larger number was associated with y, then we would have placed the a squared with y. Now, to add to our number sense, before we do more math, it is going to be a vertical ellipse or horizontal ellipse. So again, a is the larger number. Whoever is associated with a, that will let you know if you're going to have a horizontal or vertical ellipse. In this case, the larger number is associated with x. You know, a is associated with x. Because a larger number is associated with x, think about the x-axis. X-axis is horizontal. So that means that we're going to have a horizontal ellipse. Fantastic. So this is just stuff to have in the back of our mind. Now, let's go ahead, identify the center. Okay, so the center is given by the ordered pair HK. Our book focuses exclusively on ellipses centered at the origin, but I'm going to pretend like I'm surprised. Okay, so what is h, what is k? H is a number that follows the subtraction sign from the x part. So right here we have the square of x. So I'm like, okay, what are we subtracting from x? Nothing. Okay, so in this case the value of h is 0. So we have, I'm going to go ahead and write the word center because I feel like the uppercase C and the parentheses, the open parentheses pretty much look the same. Okay, so we have that the center is given by 0 comma k. What is the value of k? K is the number that follows the subtraction sign from the square of y. So I'm like, okay, what are we subtracting from the y? Same speech, nothing. Okay, so for all the problems, we're only going to do 2. But for all the problems, let's just act surprised, like, oh, look, the center is at the origin. Okay, let's go ahead, pencil it in before we forget. Okay, so where am I? So the center is given by 0, 0. Now, we have established that we have a horizontal ellipse, which means, you know, that the vertices are gonna be on this major axis. Okay, so the center is right there, and then sorry, let me clear my throat. Okay, so let me go ahead, I guess, follow the plan, and then I'll say my piece. So it would be nice if I knew what the value of a and what the value of b is. So let's go ahead, set these things equal to each other. So we have that a squared equals 9. Now, not talking about ellipses, just solving a degree 2 equation. I know that you know that the solutions of this equation is positive 3 and negative 3. But bearing in mind what a represents, let me zoom in. Okay, a represents the distance from the center to the vertex. Okay, distance is non-negative, so for that reason we're going to focus only on the principal root, or in English the positive root. When we square root both sides, that will lead to a solution of 3. Let me go ahead, highlight that. Okay, so now what is the value of b? So if b squared equals 4, then that's going to lead to a solution of 2. Same speech of why we focus on the principal or positive root. Alright, so now what about C? What are we going to do with C? You know what, let's just take a pause on all of that. Let's just find A, B, C, and then we'll tie it in together so we don't have to go so much back and forth. So now the question is, how do I find C? Okay, So let me go ahead and find C. So I'm like, okay, I know that C squared equals A squared something B squared. That is something that I'm gonna have to have in the back of my mind unless I want to build that. So my dilemma is, am I adding A squared and B squared, or am I subtracting them? You can memorize it. The way I just remember is I use the opposite operation. So for ellipses, we have a plus sign. So for C squared, we're going to have minus sign. In the next video, hyperbolas, we're going to have minus. So for C squared, we're going to have plus, so they're opposite. Okay, maybe I made a big fuss, but let's do this. Okay, so let's go ahead find C. Why? Because we want to find A, B, C, so we can locate the vertices, endpoints of the minor axis, and then the location of the focus, foci. So we have C squared is equal to A squared, and it's up to you how, oh, we have a visitor, sorry. It's up to you how you want to pencil it in. So you know that the value of A is 3. You could put 3 or square it, or you know that A squared equals 9. So we're just going to go straight to that, okay? So A squared equals 9 minus B squared. Again, you can just put 2 and then square it, or just write down the facts. B squared equals 4. Okay, so that will lead to C squared equals 5, and then the exact solution, we have C equals square root of 5. Okay, fantastic. Okay, and then it would be nice if we had a decimal approximation. I'm going to highlight this because this is what I will be submitting for credit. But of course, in order for me to locate this, it would be nice if I had a decimal approximation. To 1 decimal place, that will give us C is about, I believe, 2.2 if I punched it in correctly. Now, right now, before I get a little bit nervous, I'm going to do a very rough sketch, so then we can transpose that to our graph paper. Okay, so this is our XY plane. Okay. Do you have to do this rough sketch? No, you're cool like that. Go straight to answer, please. Okay, we have established that the center is at the origin. Surprise. We have established that we have a horizontal ellipse. Okay, so let's look at the value of A. Okay, A is 3. To locate the vertices, you know, the vertices are going to be on the major axis for the longer one. We're going to go 3 units, in this case, to the right, and 3 units to the left. Okay, so we go 1, 2, 3. That will be our first vertex, and then 3 to the other side. 1, 2, 3. Cool. Now, what about the endpoints of the minor axis, or the shorter one? Well, that will be dictated by B. Okay, so B is 2. So from the center, we're going to go up 2 units. It gets no special annotation. It's just the endpoint. And then from the center, we're going to go down 2 units. And again, you can memorize the formulas, but again, if you want to make things a little bit easier for you, just remember what A, B, and C represent. Whether we have a horizontal or a vertical ellipse, A represents distance from the center to the vertex or one of the vertices. B represents distance from the center to one of the endpoints on the minor axis, and C represents distance from the center to the foci. Okay, one of the foci. Now, let's go ahead and do this. So C is equal to square root of 5. So from the center, we're going to go square root of 5 units to the right, okay, which is about 2.2 units. So I'm going to go ahead, estimate that. And then for my peace of mind, I'm going to label these. Go ahead, put F. And then for my peace of mind, I'm going to label the coordinates here. Why do I do it here? So that way I'm not tempted to round here. So in this case, we went square root of 5 units to the right, and the value of y is 0. Okay, what about the other foci? Okay, so from the origin, we're going to go square root of 5 units to the left, which is about 2.2 units to the left. I'm going to go ahead and put my point, put the F, and then I don't have a lot of space to label. So at this point, we went to 2.2 units to the left, or to be more specific, square root of 5 units to the left, and y is 0. Okay, what are we gonna do? Let's go ahead, just connect those points, you know, the vertices and the endpoints of the minor axis. So we should have like a egg looking thing going on, or a football. Okay, so let's go ahead, fill in the blanks. I mean, what you do first, you transpose your graph or fill in this, it's really a personal choice. The reason why I like to hold the graph into the end is because I want to highlight that you know how to do this. Okay, so I don't want the actual graph paper to distract me. What are the vertices? The vertices are the endpoints of the major axis or the longer axis. So the vertices are given by 3, 0 and negative 3, 0. Let's go ahead, pencil that in. 3, 0. I put the negative one first, sorry, by mistake. I usually write how I say, but I got a little bit nervous. And the foci, we have 2, and we have said that one is positive square root of 5 comma 0, and the other one is negative square root of 5 comma 0. The question is, why don't we put the decimal approximations? We didn't put the decimal approximations because the directions didn't say round out values to 1 decimal place or whatever. Excuse me. Okay, if we're not given the green light to round, we are expected to write our answers in exact form at all times. Now, major axis length. So you can memorize the formula. Let me go ahead, spit it out. Okay, so it doesn't say right there because I didn't want to like give too much information. Okay, but if you have a horizontal ellipse, then the major axis length is given by 2a, and then the minor axis length is 2b. For a vertical ellipse, same speech. Major axis length is 2a and minor axis length is 2b. Why didn't I touch base on that? I didn't touch base on that because I felt like I would force you to memorize more than needed. Okay, so in English, how long is the major axis? Okay, so let me see if I can zoom in. Okay, wish I had another pen with me, but I don't, so we'll see how this goes. Okay, so from the center to the vertex, that is 3 units. From the center to the other vertex, that is also 3 units. Last time I checked, 3 plus 3 is 6. Okay, so to answer the question, how long is the major axis? It is 3 plus 3 units long. Or in English, it is 6 units long. What is the length of the... Oh, this is what happens when you cut and paste. Sorry, guys. Okay, this is supposed to say minor axis length. Okay, how long is the minor axis? So the shorter one. Okay, from the center to that end point, that's gonna give us 2 units. Okay, it's gonna start be looking like a pizza. Sorry, we don't have that much space. Okay, from the center to the other end point, that's also gonna be 2 units. So the question is, what is the length of the minor axis? That looked ugly. Remind me not to do that again. The length of the minor axis is given by 2 plus 2 or 4. So again, you have options. Memorize the formula. Major axis length equals 2a, minor axis length 2b. But it's so much easier if you just keep your cool and count. Okay, but do what you gotta do. Okay, so we answered everything that we need to graph. We actually graphed it already. We just need to earn our credit, or not earn, but like redeem our credit by transposing it. Okay, so this should go a little bit smoother because I'm just gonna copy what we wrote down, and then what we graphed. Okay, so the center is at 0, 0. Do you have to graph the center? Not really, but if I'm graphing it for the first time without a sketch, oh yeah, I will totally graph it, because that way I'm like, okay, how many units do I go to the right, to the left, up, down? Vertices, we had said that they were negative 3, 0 and 3, 0. Endpoints of the minor axis are not listed here, but we had said we go up to, down to. Okay, so in terms of coordinates, 0, 2, let me go ahead, zoom in. Okay, 0, 2, and then 0, negative 2. Okay, we are asked to include the coordinates of the foci. Okay, so we had said there were a square root of 5 comma 0, which I have no idea what that is, but the decimal approximation was 2.2. Okay, so the one of the focus is 2.2 comma 0. Let me go ahead put my F. I'll put V while I'm at it. And the other one is at negative 2.2 comma 0. You go ahead, put F and then V. Okay. All right. So I think we're good to go. So let's go ahead, do our best to connect all those points and to have a nice smooth egg. Okay. Nice doesn't always happen. Okay. If you're a football fan, I'm not. Go ahead, make it look like a football. Okay, so I could have done better, but it's okay. I tried. Okay, so we answered, we graphed the ellipse as best as we can. We've identified the center, the vertices, the foci, the length of the major and minor axes. We included the graph of the first foci. So that's it. We earned our full credit. Okay, so ellipses are not they're not terribly bad, but I want to give you both case scenarios. I want to give you a horizontal ellipse, and the second one will be a vertical ellipse. Let me go ahead and grab it. Okay, so the directions are the same. Pretend I read them. Okay, so the punchline is that we are asked to graph the ellipse. Okay, so the standard equation of an ellipse, whether it's vertical or horizontal ellipse, it's something like square of x minus h over something plus is key. Okay, in the next video we're gonna have minus, and that small tweak will make it a different graph, plus the square of y minus k over something equals 1. Okay, 1 being the key. Now, how do I know who's gonna get the a squared? Well, that depends who has the bigger number. Okay, so I just have to remind myself that for ellipses, a has to be greater than b. At this point, because the equation is not set equal to 1, I can't make the call of who is a, who is b. Let's go ahead, set it equal to 1. So to make the 24 look like a 1, let's go ahead, divide both sides by 24. And then reduce as needed. So the first part of the puzzle, that will give us x squared equals 8, plus the second part of the puzzle, that will give us y squared over 12, and that should equal 1. So now the question is, who has the bigger number? Okay, well, what number is bigger? So I know that you know that 12 is bigger than 8, so the 12 is going to be associated with the a. Okay, so this will be our a squared, and that will be our b squared. Okay, so let's go ahead, put that in our formula. So the larger number has to be associated with y, and the smaller number has to be associated with the b. Now, because the larger number is associated with the y, that means that we're going to have a vertical ellipse. Think about it. Y, that should remind you of the y-axis. Y-axis is vertical. Fantastic. Okay, so now it's up to you what you want to identify next. For me, I want to identify the center. Again, our book stresses only on ellipses centered at the origin, but we're going to pretend like we're surprised. Okay, so the center of the ellipse is given by the ordered pair HK. Let's go ahead, find h. For the square of something x, I want to know what is the value of h. What are we subtracting from the x? Well, in this case, we're not subtracting anything from the x. So that means that the value of h is 0, because x minus 0, yeah, it's still x. Okay, so the center is given by 0 comma k. Okay, what are we subtracting from the y? Same speech, nothing. Okay, we're not subtracting anything from the y, so the value of k is also 0. Fantastic. So we have the center nailed, and then let's go ahead, pencil it in right now because we're overachievers. So let's go ahead. Well, we have identified what's a squared and what's b squared, but it would be nice if we actually knew the value of a and b. Okay, so a squared is equal to 12. Let's go ahead, square root both sides, and that will give us a equals whatever the square root of 12 simplifies to. It would be nice if we can simplify the radical, and we always want the answer in exact form. Then we'll use a calculator to give a decimal equivalent to make it easier to, to make it easier to identify the vertices. So I know you can simplify in your head, but I cannot. 12, perfect square factor is 4, so we're going to write that as square root of 4 times square root of 3, and that will simplify to 2 square root of 3. So let's go ahead. Where am I? I'm going to go ahead and do my quick sketch. Where should I do that? I guess I'll do it right here. So we have established that the center is given by the origin, or 0, 0. We have established that we have a vertical ellipse. Okay, so from the center, to identify the vertices, we're gonna go 2 square root of 3 units up from the center, and then 2 square root of 3 units down. I mean, I could just put the actual number, but I want to put a decimal approximation. So if I keep my cool, and if I did this right, I think A was about, what was it, 3.4. Okay, so to find the vertices, we're going to go about 3.4 units up. So let me just put one tick mark. I'll put 3.4, and then in parentheses, I'll put 2 square root of 3. And then we're going to go 3.4 units down. So I'll just put negative 2 square root of 3. So I hope that in my effort of not putting all those tick marks, I'm not hurting you instead of helping you. Okay, so let's go ahead, write down those endpoints. Okay, so the endpoints. Let's go ahead, write down those vertices. So those vertices, x is 0 and y is about 3.4, which is exactly 2 square root of 3 units. Okay, the bottom vertex, x is 0 and y is about negative 3.4, which is negative 2 square root of 3 units. Okay, let's go ahead, lock those in. I don't really care which one you write first, as long as you put 1. Bear in mind that your book may just put 0 comma plus or minus 2 square root of 3, but that's like one of my pet peeves. It doesn't really highlight that we have 2 distinct answers. Well, I need to make sure that you understand that we have 2 distinct answers. So that's why your answers should never be submitted without the plus or minus. Remember, the book does not grade you. Cool. What should you identify next? That's a personal choice. We do have to identify the endpoints of the minor axis, and we also have to identify the foci. I'm going to go ahead find the endpoints of the minor axis, or the shorter one. Okay, so we have that. Let me go ahead and move this. Okay, so we have that b squared equals 8. So when we square root both sides, that will give us b equals square root of 8. Of course, we are going to use the decimal approximation, but we want exact answers unless we're asked to ground. When we keep our cool, a perfect square factor of 8 is also 4, so we're going to rewrite square root of 8 as square root of 4 times square root of 3, and that will give us 2 square root of 3. Okay, so what is going on? From the center, we're going to go 2 square root 3 units to the right, 2 square root 3 units to the left. Okay, in terms of decimal approximation, if I punched it in correctly, that's about 2.8. Okay, so we're gonna go about 2.8 units to the right, which was, what was it, 2 square root of 3, and then 2.8 units to the left, which was negative 2 square root of 3. Okay, so let's go ahead, write down the coordinates of those endpoints. Do we really have to? No, I'm just doing it for me, for fake extra credit. So this one is given by 2 square root of 3 comma 0, and then this one is given by negative 2 square root of 3 comma 0. So let's go ahead, do our ellipse. Because I don't have graph paper, it may look like a circle. Well, not even that. Okay, but hopefully I'll have a better visual over here. Now, what about the foci? So remember, we need to find c. Okay, so let's go ahead, write down the formula. So we have c squared equals a squared something b squared, and then I'm like, oh, okay, is it plus b squared or minus b squared? So just remember, whatever you have, if you have for ellipse, if you need a plus, for c squared, you're going to do the opposite operation, or minus. Okay, so let's plug and chug. So we have c squared equals a squared. You're going to digest this however you want. You can put the actual value of a, which is 2 square root of 3, and then square it. But you know what a squared is. You know, whether you go straight to 12 or you square 2 root 3, you're going to get 12. The choice is up to you. I'll take the easy way out. So we have c squared equals a squared minus b squared, and same speech. You could put 2 root 3 and then square it, or just go down to what it simplifies to, which is 8. So that will lead to c squared equals, okay, sorry, I was having a moment after like 2 brutal answers. I couldn't believe that was a perfect square. Oh, I'll take that gift. Okay, so when we square root both sides, that will give us that c equals 2. What's so special about c? C represents the distance from the center to the focus, okay, to one of them. So in this case, we're gonna go 2 units up, so that will give us where am I? That will give us 0, 2. Yeah, you cannot see that. Okay, and then we're gonna go 2 units down. Let me highlight that. When we go 2 units down, remind me to put my tick marks next time. Okay, I think I do need them. So that will give us 0, comma, -2. So I'm gonna pretend you can read all of this, okay? But I will make sure that we have more space over here. So let's go ahead fill in what we can. Okay, the foci, we had said that one of them is at 0, 2. Pretend that looks like a 0, and the other one is at 0, -2. Fantastic. Major axis length, you have options. Option 1, memorize the formula. Formula is that this equals 2a, or you can just count. We have established that we have a vertical ellipse, and this is in my way, so I'm not gonna make this tougher. Okay, so we just go like this. So we have this is 2 root 3. This is -2 root 3. Okay, so how long, what is the length of the major axis? From the center to the vertex, that is going to be 2 root 3. This is a brace, but it's hard for me to do a close brace. From the center to that bottom vertex, the distance is also 2 root 3. Last time I checked, the sum of 2 root 3 and 2 root 3 gives us 4 root 3. Okay, so without having to memorize the formula, we can just count. Okay, the major axis length is 4 root 3 units. Cool. Now, I normally don't do another graph area, but there's like a lot of scribbles, so I'm gonna do another graph area. So again, I cut and paste the first time, and I cut and paste the second time. There are dangers to cutting and pasting. Okay, so this should read minor axis length. So let me go ahead, pencil that in. What is the length of the minor axis, or the shorter axis? So I need to start from scratch. Okay, so the endpoints of the minor axis, where am I? I think I applied the wrong one. They're not the same. Oh, I should be fired. Okay, okay. Apparently I don't know that 4 times 3 is not 8. 4 times 2 is 8. So let's go ahead, update that. Should I start the video to save my embarrassment? Of course not. Okay. Now, by some miracle, I simplified it wrong, but I still got the right answer. Why? Because I cheated. Okay, exactly. But I don't know how to cheat correctly. Now, I was looking at my notes. Okay, for my notes, I had 2.8, but I didn't look at my notes. So let's go ahead, update this. Okay. So the 2.8 is correct because I cheated. I got it off my notes, okay? But if I punch it into the calculator, 2 square root of 3 gives us 3.4, okay? Good thing that I did a little quick sketch here, okay? So for the endpoints of the minor axis, we should go 2 square root of 2 units to the right, which is about 2.8. I'm just gonna update this. Okay, and then we should go 2 square root of 2 units to the left, which is still about -2.8 because I cheated. Oh man, if I'm gonna cheat, I should know how to cheat, right? Huh? Don't cheat, guys. Okay, don't cheat. Never do that. Cheating is bad. All right. So coming back to the problem, minor axis length. Okay. So where am I? Okay, so in this case, from the center to the endpoint of the minor axis, we're at 2 root 2. From the center to the endpoint of the endpoint at the other side, we're at -2 root 2. So the question is, what is the length? Okay, well, we're gonna have from this endpoint to the center 2√2 units. From this endpoint to the center, we're gonna have another 2√2 units. We keep our cool and add 2 square root of 2 plus 2 square root of 2 will give us 4 square root of 2. Okay, fantastic. So let's go ahead, earn our full credit. Cool. All right, so let's go ahead and do this. So we updated this, which was give me a sec, I have a person coming in. Okay, sorry about that, guys, but they say working from home is easy. I can attest to it. It's not. Okay, so apparently I don't know my difference between up and down, side to side, and hence this little band-aid. Okay, so let's do this. So we have everything that we need, you know, to graph the ellipse. Okay, so we did the sketch. All we have to do is transpose it to our actual graph area. We identified everything that we were asked to do. Let's go ahead, earn our full credit. So the center is at 0, 0. The vertices are at 0, 2√3 and at 0, negative 2√3. So we stay put and go 2√3 units up, which is about 3.4. You don't have to label the coordinates unless you want to. As long as we put them in the fill in the blanks, we're good. But I'm going to put a V for my peace of mind. So we have 0, 2√3 and 0, negative 2√3, which is negative 3.4. I'll put a V, and then I'll locate the endpoints of the minor axis or the shorter axis. So we have 2√2, 0 or 2.8 units to the right, 2.8, 0. So use your best judgment, and then negative 2.8, 0. To be more specific, it's going to be negative 2 square root of 2. We are also, so let's go ahead and do our ellipse, and then we'll do the foci. Okay, so we're going to do the best to do an egg looking shape. I feel like I graphed this wrong. 3.4, yeah, that's fine. It just looks weird to me. So let's go ahead, try. All I ask is that you try. I'm going to try to make it as round as possible, but as you can see, that simply just didn't happen. I tried to redeem myself by tracing it over and over, but that looks worse. Remind me not to do that again. So it's this is why I use pencil whenever possible. We're good with the ellipse. The only thing that we're missing is to I can't project the directions because I have a band-aid on. But it said to locate at least 4 points on the ellipse, and the first 2 will come from the vertices and the next 2 will come from the endpoints of the minor axis. But one thing that we are asked to include is the graph of the foci. So the foci, it's at 0, 2, so we stay put, go up 2. And you don't have to put an F. It's just easier for me to digest. So when I look at my notes, I'm like, okay, what's so special about that point? Okay, and the other one is at 0, negative 2. Okay, so we graphed the ellipse, and then we answered all the problems, so we're good to go. Cool. So that's the end in terms of graphing, but I have 2 more problems for you. Some problems where we have to find equations. Give me a sec. Okay guys, so let's go ahead, I'll wrap it up with our third and final problem. So as you can see, there's no graph paper, so we're going to take a small break from graphing. That doesn't mean that we're going to deviate from today's agenda, which is our ellipses. Okay, so the directions read, find an equation of an ellipse in the form x squared over n plus y squared over n equals 1 if the center is at the origin. And so we have 2 sets of problems. Let's go ahead and knock out the first problem. Now I know that you know that we have, in terms of ellipses, we have vertical ellipse and then we have a horizontal ellipse. How can we tell? So whoever has the larger number in the denominator, that will dictate if we're going to have a vertical or horizontal ellipse. The question is, how come the problem didn't put a squared b squared or b squared a squared? And the reason is because they wanted for you to do the detective work to determine if we're gonna have a vertical or horizontal ellipse. Okay, so for problem A, what do we know? Let me just write down the facts before I read problem A. Find an equation of an ellipse. Okay, so we have an ellipse. They want us to put it in this form. If the center is at the origin, so let me write that out. Center is at the origin, okay, and then the following hold true. Okay, so let me just go ahead do my my fake graph paper or my XY plane. And then do we have to do this? No. I mean, if you can just read the problem and be like, bam, that's my answer, then go for it. But I'm not as bright as you, so I really need to speak to myself. So let's do this. So the center is at the origin. The problem didn't reference if we have a vertical horizontal ellipse, so let's do this. It says major axis on y-axis. So the longer axis is on the y-axis. So it's gonna be right here. So that's code for vertical ellipse. Okay, bam. Okay, so what do we know? Major axis length is 24. Okay, so if the major axis is on the y-axis, then the vertices are gonna be the endpoints of the major axis. Okay, now what do we know about the length? Like, supposedly these are supposed to be the same length, but things happen. What do we know about the length of the major axis? So the major axis length is 24. So if the whole way across from vertex to vertex is 24, the halfway from the center to the vertex should be 12. Okay, so let's go ahead, take that 24 and divide it by 2, and that will give us 12. Okay, whole way across is 24, halfway across is 12. Now, before I keep moving forward, let me go ahead and speak to myself. So we should have an ellipse of the form x squared over a number plus y squared over a number equals 1. Before I crunch in my numbers, I want to put the a squared and b squared where we go. The major axis is on the y-axis. So for ellipses, we have to bear in mind that a has to be greater than b. What's so special about a? A represents the distance from the center to the vertex. Okay, so in this case, a equals 12. So 12 will have to be associated with the y. So let's go ahead, let me just go ahead and put the formula y. So we should have a squared and then b squared. Again, why do we put a with the y? Well, that's because the major axis is vertical, so the a has to be associated with y. Fantastic. So let's go ahead and read the rest. What else do we know about this problem? We know that the minor axis length is 18. Okay, so the minor axis length, that is the shorter side. So let's go ahead and locate those endpoints. They have no special annotations. Depending on your book, they may say co-vertex, but that's like too much for me. For me, I'm just like vertices. What are those? Endpoints of the major axis. And then endpoints of the minor axis, we give it no special laugh. If you want to call it co-vertex, go for it. Now, what do we know about the length of the minor axis? We know that the whole way across is 18. Cool. So that means that when we take 18 and divide it by 2, that will give us the distance from the center to the endpoint of the minor axis. So this will give us 9. Okay, so those are braces. It's hard for me to do. Okay, so that will give us our b. What is the meaning of b? B represents the distance from the center to endpoints on the minor axis. Okay, so we have a, we have b. That's it. We don't need a c. Okay, I was gonna find the value of c because I'm an overachiever, but in order for us to write the equation of the ellipse centered at the origin, all we need is a and b. We have a and b identified. Let's go ahead and earn our full credit. So that will give us x squared over b squared. We have established that since the whole way across is 18, halfway across is 9, so that will give us 9 squared plus y squared over a squared, and we have established that the value of a is 12. Cool, that's our answer. But let's go ahead, clean up the expression. The square of 9 is 81, plus the square of 12 is 144. And the question is, should we clear the fractions? Of course not. Why not? Because if we clear the fractions, then we're not going to write the equation in standard form for the ellipse. In English, it needs to be set equal to 1. plus who wants to wipe out the fractions, but the main reason is because we need to have it set equal to 1. Okay, so to wrap up this video, let's do this. So remember, pause and rewind as many times as needed. Okay, so from the prompt, I can't display it right now, but we want to find the equation of an ellipse, and the ellipse has to be centered at the origin. So let me just go ahead, write down that the center is at the origin. Okay, so we should have something that I failed to put is just writing down the standard form. Okay, so square of x minus h plus square of minus k over something equals 1. The reason why I didn't put x minus h and y minus k before is because the problem, where am I? The problem, I just wrote x squared, so I just copied it, but I just want to remember one thing. So if I do it like this, I feel like I just have to remember one thing instead of two. So let me go ahead, zoom in. Let me go ahead, use my bad notation. I'll put a question mark because I'm not quite ready to commit which one is A, which one is B. We know that the center is at the origin, so we have h, k. Let's substitute a 0 for h and a 0 for k. Let me cross out this h, put a 0, cross out that k, put a 0 for time purposes. You know, x minus 0 is just x, and we have to square it, so we still have x squared over something plus y squared over something. Okay, so now it's like we're coming to what the book said. Write the equation of the ellipse in this form. You know, x squared over something plus y squared over something equals 1. Now, without reading any additional information, I'm not ready to confirm which one is the major axis. Are we going to have a horizontal ellipse or a vertical ellipse? So let's do this. So we have major axis on the x-axis. Okay. So the x-axis is right here, and if the major axis is on the x-axis, that is code for we are going to have a horizontal ellipse. So bear in mind that because for ellipses A has to be greater than B, then A will have to be associated with the x. That's the only way we're going to have a horizontal ellipse. So this will be A squared, B squared. So now we need to do same thing. We need to find A, B, plug in, check, and that's it. Okay, so we know that the major axis is on the x-axis, so that is code for excuse me, we have a horizontal ellipse. Minor axis length is 14, so the shorter axis is 14, so the whole way across is 14, halfway across will be 7. Okay, so the book told us that the center is at 0, 0. Okay, the major axis is across, so the minor axis, this should be 14. Okay, so we're gonna go 7 units up, 7 units down. Okay, so that is code for B equals 7. Fantastic. So let me just put my points here for dramatic effect. I don't really have to. I did it for fake extra credit. Now, we know what the value of B is. Fantastic. But now what we need to know is find the value of A. Okay. Now, third statement, distance of foci from the center equals square root of 200. How I wish that they told me that the distance from the center to the vertex was whatever it was, because that would give us the value of A. Okay, A represents distance from the center to the vertex, but they don't tell us, so they give us something with foci. Okay, the distance from the center, the distance of the foci from the center is square root of 200. So let's go ahead and write down the facts. Okay, so let me go ahead and write down the formula to calculate C. I don't have it memorized. C equals, I just remembered with the square. So C squared equals A squared something B squared. For now, you know, I just remember that it's minus. When we touch base on hyperbolas, I just remember that it's the opposite. Cool. So let's plug in what we know. Okay, distance of foci from center is square root of 200. What does C represent? Distance of foci from center. So that is code for C equals square root of 200. Okay, so we have C, which is the distance from the center to the foci, is square root of 200. But we're gonna take our C and square it, and that will give us A. We don't know what the distance from the center to the vertex is, so A is still unknown, minus B squared. Thanks to your detective skills, we know that the distance from the center to the endpoint of the minor axis is 7, so that is code for B equals 7. Okay, let's go ahead, plug and chug, and solve for A or A squared, depending on how you want to digest it. On the left side, the square and the square root undo each other, and that will leave us with 200 is equal to A squared minus 49. Let's take our time to isolate the A squared. Let's go ahead, add 49 to both sides, and that will give us 249 equals A squared. And this is how it's gonna go down. The overachiever in me wants to solve for A, and I guess you could, but think about it. Okay, what do we need? We wanted to find A, and once we found it, we will square it, but we already know what the square of A is, so it's really not vital that you square root it so then you can square it later. I mean, keep your cool, you got this. So to answer the question, the ellipse is given by x squared over A squared, which is 249, and then we're gonna add to it y squared over B squared. Value of B is 7, and then you can square it in your head, but you know what, when you're tired, 2 plus 3, I don't even know, so I'm gonna show on my work. When I show on my work, it also minimizes those technical difficulties. I've had a few in the videos because I try to show off my amazing arithmetic, yeah, which is non-existent. Okay guys, so we were asked to find the equation of the ellipse centered at the origin, and in this case, what's so special about ellipse? We needed to have the major axis on the x-axis, minor axis length of 14, and distance of foci from the center equals square root of 200. We have it in that form, so we're good to go. Okay, we did it guys. I'll see you in the next vid.